Good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on transverse waves. So let's begin with the worksheet. So here is the worksheet on transverse waves. So the first question is, for transverse waves, angle between particle velocity and wave velocity, so it is 90 degree. As you can see over here, wave is moving along x-axis and particles are vibrating along y-axis. Next is speed of transverse wave. So in a string, speed of transverse wave is root under T by mu, where T is the tension in the string and mu is the mass per unit length. Next is Vt graph. So from here we can see that V is proportional to root T. So the graph will be a parabola turning toward T axis like this. Then we have a graph between V versus root T. So graph between V versus root T will be a straight line as shown in the figure. Then is the graph between V and mu. So V is proportional to 1 by root mu. That means graph will be having a shape like rectangular hyperbola. It is shape like, because exact equation is it should be proportional to 1 by u. Next is if we draw graph between V versus 1 by mu. So we can say that we take 1 by mu as x. So V is proportional to root x. So again the graph will be a parabola. Next is graph between V and 1 by root mu. So take 1 by root mu as x. So we can say that V is proportional to x. So the graph again will be a straight line. Next we have a question that a wave pulse is generated in a string having mass m and length l, and at a certain point which is at a distance of x from the top. We need to find the speed of transverse wave at that point. So using the equation V is equals to root T by mu. So tension will be equal to the mass of the weight of the string below this part. So mass per unit length is m by l, and if this is x, then this length of the lower part, that is going to be l minus x. So that will be L minus x into g. Mu is mass per unit length. So speed comes out to be root g into L minus x. Next is Vx graph. So the Vx graph here will be a parabola, and at x is equal to 0, V will be root gl, and at x is equal to L, V will be 0. So it will be a parabola like this. Next is time taken by pulse to move from A to B. So we take V as dx by dt, which will be this. So integrating the above expression, we get T as 2 root L by G. Next question is wavelength at A is lambda. Find wavelength at B. B is this point. So here we can say that frequency remains same. So V1 by lambda 1 is V2 by lambda 2. And we can see that at point B, tension will be 0. So that means lambda 2 will also be 0 at this point.